Continuing with section 11.2, we started looking at series. Remember, a series is a sum of terms of a sequence, and a sequence is just a list of numbers. So there is a big difference between a series and a sequence. So sequence is something like A1, comma A2, comma A3, comma dot dot dot, and a series will be A1 plus A2 plus A3 plus dot dot dot. So we also looked at in section 11.1 how to check whether a sequence converges or diverges. Basically, we just look at the limit of the nth term. So if this limit exists, then we say series converges, and if sequence converges, and if this limit does not exist, we say sequence diverges. But now what about series? So that is our question. And can we say a series converges or diverges, and when can we say that? So this is not that straightforward as compared to the sequence. So we started looking at different types of series, and the first type that we looked at was geometric series. And the general form of a geometric series is something like this in the summation notation, or you can write it like that. In both cases, when you expand, you will get this. Now notice here we can even factor out the a. If we do that, we end up getting a times 1 plus r square plus r cube plus dot dot dot. So once you write it like this, you can easily see what a is and what r is. So we saw in the last video that a geometric series is convergent if the value of the r satisfies this condition, which means the absolute value of r is less than 1. Now remember, this inequality can be split into two inequalities like this, and then depending on the r, you should be able to solve it. Now if the absolute value of r is greater than or equal to 1, the geometric series is divergent, and we saw some examples of geometric series previously. Now we are going to use the geometric series in a little bit different way to help us actually figure out what is the fraction associated with a repeating decimal. Now remember that if you have a terminating decimal, so for example if you had 0.12, we can easily write it as 12 over 100, and then because 4 goes into both, so you can write it as 3 over 25, and that is your fraction associated with this decimal 0.12. But if it is a repeating decimal, then it is not that straightforward what our fraction will be. But the geometric series helps us find it. So this is how we do it. We start first by writing this expression as to actually what the number is. So remember, this means the number is 0.12121212 dot dot dot. So it's repeating forever. What we do next is we split this and write it as a sum of numbers. So how do we write that sum? Well, we try to keep the repeating numbers together. So what that means is these two are repeating this two, so we want to keep them together. So the first number or the term is 0.12 plus, now the second one will be 0.0012, the next will be 0.000012 plus dot dot dot. So notice how we write this. Now you can write each of them as a fraction. So this is 12 over 100 plus 12 over, so what will this be? Well, you have to, the way you convert it into fraction, remember, is that you kind of think of it like this, that in place of the decimal you are putting a 1, and then you count how many decimal places you have to the right of the decimal. So we have 1, 2, 3, 4, so that means we have 4 zeros here. plus in the same way. Now you can see there are 6 decimal places to the right of the decimal sign on the next term, so we have 6 zeros and then plus so on. Now notice that this can be written as 12 over 10 squared plus 12 over 10 to the 4th plus 12 over 10 to the 6th plus dot dot dot. So now, as I explained before, what we were looking at over here, we now will take, because we can do that, will take 12 over 10 squared common or factor it out. So inside we are left with 1 plus 1 over 10 squared plus 1 over 10 to the 4 plus dot dot dot. So notice from here our A is 12 over 10 squared and our R is 1 over 10 squared. In other words, A is 12 over 100 and R is 1 over 100. So that A over 1 minus R is 12 over 100 divided by 1 minus 1 over 100. So we get 12 over 100 over 99 over 100, which gives us 12 over 99, or we simplify and because 4 actually goes in, 3 goes into both. So 3 times 4 is 12 and then divided by 33. So that is your fraction. Let us look at one more example. So now I have 2.317 as our, and we want to write it as a fraction. So notice here the 3 digits are repeating now. Again, it doesn't matter how many digits we have as repeating. We start by writing, expanding it and writing it as a sum. So we have 317. So this is 2.317, 317, 317, dot dot dot. So now when we write it as a sum, so first thing, the 2.3, actually 2 is kind of extra. So we will separate it, and then 317, 317, 317, these are repeating. So this is the first set, this is the second set, third set, and so on. So we will write 0.317 plus 0.000, we replace these ones by zeros, and 317 plus, again you can see now we will have 6 zeros and then 317 plus dot dot dot. So this is kind of an important step, because if you wrote this one wrong, then your rest of the problem can be wrong and the answer will be wrong. So 2 is just there, and we can write this one as 317 over 1000 plus 317 over how many? 6 zeros, and then 317 over, now we will have 9 zeros and plus dot dot dot. So you keep the 2 as it is, plus now I do the same thing, I factor out. Now you don't have to do this step of factoring out. If you can see already what your A is and what your R is, you can directly write from there, which I'm just going to do it that way. So you should be able to see that A is 317 over 1000. So A is 317 over 1000 and R is 1 over 1000. So that A over 1 minus R will be equal to 317 over 1000 over 1 minus 1 over 1000. So which gives us 317 over 1000 over 999 over 1000, and which gives us 317 over 999. But this is not the answer. Remember, this is just the sum of this piece. So our value, the 2.317 repeating, will be equal to 2 plus 317 over 999, and you take a calculator and do that summation, and you end up getting so you'll notice that you get 2315 over 999. So this way we can write the continuing or decimal or non-terminating and repeating decimals as fractions. The next example is we have to see that these are geometric series, and we have to find the values of x for which they are convergent, and once we find the value, we should be able to figure out what r is and what a is, and then we should be able to write our sum of the series. So we start by expanding it, because that will help us determine what is our a and what is our r. So in this case, because series is starting at n is equal to 3 here, so our first term will be x plus 1 raised to 3. The next one will be x plus 1 raised to 4, x plus 1 raised to 5, and so on. So which is giving you that a is x plus 1 whole cubed and r is just x plus 1. So to converge, we must have that absolute value of r is less than 1, which means absolute value of x plus 1 is less than 1. And now, because we needed to find the values of x, so we expand this inequality, and we get negative 1 is less than x plus 1 is less than 1. So we want the values on x, so we subtract the 1 from there, and we end up getting negative 2 is less than x is less than 0. So this is we say converges on negative 2 to 0. So it will converge if x is in this interval. So what is the sum now? So you can write the whole inequality, or you just can say sum equals. So remember, it's going to be a over 1 minus r. So a is x plus 1 whole cubed, and the r is x plus 1, so 1 minus x plus 1. Simplify, we end up getting a x plus 1 whole cube over x negative x. So that is your sum. Looking at the next example, the n actually starts at 0 here. So if n is starting at 0, what will be the first term? So first term will be just 1, because anything raised to power 0 is 1. The next will be negative 4 into x minus 5. The next will be plus 4 square into x minus 5 whole squared. Next will be negative 4 cubed into x minus 5 whole cube, plus dot dot dot. So from here you notice that a is 1 and r is negative 4 into x minus 5. Now to converge, we must have that absolute value of r is less than 1, which means the absolute value of this quantity is less than 1. But remember, the absolute value basically just consumes the negative sign. So we are getting absolute value of 4 into x minus 5 is less than 1. And now we solve this absolute inequality by writing negative 1 is less than 4 into x minus 5 is less than 1. So now you can do it in two ways. You can either first divide by 4 and then add 5, or we can distribute this 4. This will be easier. So 4x minus 20 is less than 1. Now I add 20 to the 3 pieces, So we end up getting 19 is less than 4x is less than 21. Now divide by 4, so we end up getting 19 over 4 is less than x is less than 21 over 4. So this is the interval, or you can say converges on 19 over 4 comma 21 over 4. So what is the sum here in this case? So the sum will be a over 1 minus r. So a over 1 minus r. Now a was 1, so 1 over 1 minus r, which means 1 plus 4 into x minus 5, and simplify and you get 1 over 4x minus 19.